Hey, everybody. So we're here for the session, How to Get Visibility of Your True Attack Surface. My name's Mike Hindman, and with me is Abhinav Tiwari, and we both work on clicker's not working. That's okay. We'll do it manually, the old-fashioned way. I am VP of Product for Risk-Based Solutions, and with me is Abhinav, who is our Global UX Design Head, as well as Senior Director of Product for Risk-Based Solutions. We're here to talk to you about EASM. So we're going to cover what is attack surface, why organizations lack attack surface visibility, how do you reduce your attack surface, case studies and examples around this area, and then we're going to hop in and give you a little bit of a product overview as well.
Right. I can get started. Let's start to learn about what is attack surface. What do you know about attack surface? So basically, attack surface is the sum of both known and unknown assets. External attack surface is what is visible to the internet. Typically, these are all the entry points that attacker or hacker can use to get access to a system. So all the assets that you have can be broadly classified into three categories. The one on the left is your managed assets that you're aware of, including your endpoints, servers, network, IoT devices, and all that. The one on the right is your third-party assets, belong to your third-party vendors. You are probably aware of it, but do not really have control over those, too much control. The one in the middle is the main concern. These are unknown assets, your shadow ID, your cloud stores, test data, your code repositories, and unused credentials that can be easily used as an entry point for the attacker. So all these three combined together build your attack surface. And like I said, the external ones are the ones that are exposed. We'll talk about that in a minute. Let's talk about the customer challenges these days that are causing this word attack surface management, going the hype cycle for Gartner, and people are being talked about this a lot. So what are the reasons, right? So organizations today, they operate in a pretty complex IT environment that include like on-premise systems, the cloud servers, mobile devices, even BYOD devices. So they kind of, they limit your visibility to those devices, and then definitely add to your attack surface because of these diverse environment that all devices or assets are being used in. Rising cybersecurity threats, cybersecurity attackers, basically they are being very sophisticated these days. The moment you think that you are using up-to-date tools to make sure of your risk, trust me, attackers are like 10 steps ahead of you. They're already thinking forward and they're getting sophisticated in these attack techniques. Phishing and social engineering attacks, these are techniques that are currently being trending by attackers. They use it a lot to get an easy access to an entry points. Regulatory compliance requirements like HIPAA, your GDPR, PCI, they're being more strict day by day, and they also pose a huge challenge for your attack surface because if you do not know your assets or a lot of those things are unknown, that are beyond your control, you're going to be in trouble with this compliances. And of course, the third-party risk, I did mention in previous session about the attack that happened with the Target about 10 years ago, that attackers got an easy access to their HVAC third-party vendor and affected millions of customers. So attackers see this as a very easy entry point through a third-party vendor. And these supply chain vulnerabilities add to your attack surface. And attack surface management, in a way, it kind of helps with all these challenges. We'll talk about that in a minute. According to Gartner, Forrester, and Gartner would agree to this as well, that people are being aware of this with every day. Like 72% of decision makers, they are either they have adopted or currently in the process of adopting EASM. The reason being that if you're aware of all these attacks happening, ransomware attacks and all exploits being currently carried out by attackers, they are being aware that there is a need for ESM tools, and if you one WannaCry attack that comes to my mind happened 2017, I believe, where there was a Microsoft Windows OS vulnerability. I forgot the name, but that was exploited. That it exposed around almost like 250,000 users, and there was a big, I think, Telefonica is a Spanish telecommunication company that got affected, and it was a huge issue for them. So these kind of use cases that you come across, these security leaders, they are being aware, and then they want to adapt to a ESM to make sure that those kind of attacks don't happen. So how do you measure cybersecurity risk? I think Mike can go over this real quick.
Sure, yeah. So what you're looking at here is sort of a description of 3 stratospheres of assets. The first one is something that I think hopefully Ivanti is helping you with, as well as many other security products that you might have. These are going to be official domains, valid certificates, assets with agents on them, your internal network, the VPN networks that you know about, all these sorts of things. Moving out into the second ring here, you start looking at things that you may know exist, but you don't know are necessarily exposed. And so those things could be S3 buckets, right? Obviously, you're aware that you're using S3, but you may not be aware that somebody accidentally messed up a configuration, and now the S3 bucket is publicly available. This is actually the attack vector a few years back in a big financial institution situation was misconfigured S3 buckets. And finally, the last ring are things that you probably don't know exist, and you don't know that are exposed. And these are going to be things like dev and QA environments that may be out there that you're unaware of, and a large portion of shadow IT. And shadow IT comes in many shapes and sizes, but if you want one of the easiest examples, it's I gave Bob the directive to go get XYZ done. I told him he could hire an intern. That intern fired up a machine, convinced somebody, at a happy hour to open up the firewall and NAT the inside so that he could make it available to people at another site. And all of a sudden you have a machine under Bob's desk that an intern is no longer here for, that is running something that was created for people that are using it, that is exposed to the internet, and nobody knows about it. That's probably a pretty bleak description, but that's the type of thing where shadow IT comes in. It may be a little bit less of underneath Bob's desk today, and maybe, you operate out of Azure and all of a sudden you have assets in GCP. Why we don't operate in GCP, but somebody's operating in GCP from your organization potentially. So how do we discover that? This is a picture of kind of the majority of the types of information that EASM, our EASM technology, is going to be looking at. I'm not going to go over all of it in depth, but we can talk about quite a bit of it here. So we're going to be looking at ports and protocols and services from multiple sources. We're going to be looking at subdomains and enumerating them. DNS records that are out there that belong to you and your company. Whois records for those people that are not hiding Whois records, or for those people who have Whois records show up because you are hiding them, but somebody from marketing somehow got somebody to keep picking in marketing. Somebody somehow got somebody convinced to go get them their own domain for something, or they decided they were going to sign up for it, and lo and behold, you have something from GoDaddy with Whois information tying that back to your company, which is sort of an information exposure type situation that you typically don't want to have. Whois can be made private, and many organizations that haven't yet, it basically just gives a map of what assets do you own and where can I start looking for entry points into your network. Data leakage. These are from both proprietary and non-proprietary sources, like Have I Been Pwned, for example, looking at data dumps, paste bins, whether or not the organization has users and emails showing up in in those things, what types of breaches they're involved with, and how much data was leaked. Was it just usernames and emails? Was it home addresses? Was it credentials themselves? SSL and TLS, are you using it? Are you using the correct ciphers? Are you using, do you have expired certs? Do you have self-signed certs that are available on the internet? Typically not something that you want to promote, right? If you're going to put something on the internet, you should make it an official cert. Self-signed certs are typically for internal network most of the time. If you give us net blocks, then we'll of course monitor them. We don't go out and search for what net blocks that you own. But if you, in the configuration of the tool, if you give us those net blocks and put them in, then we'll have them. Lateral domains. And lastly, API endpoints. The web and the tech stack is, looking at things like your storefront or your marketing website and looking at the technologies that they're using, right? You can introspect the DOM and see, are they using WordPress or Drupal or, an old version of jQuery as a good example. I see a lot of sites still using today. So all those pieces of information, again, publicly available information, it's out there. And that's why ESM tools are commonly referred to as the hacker's view of your external surface, right? Because I don't need any permission to go get this stuff today. I could be at Ivanti or not be at Ivanti. I could be at any other company. I could be a white hat or a black hat hacker. And all this information is something that if I know where to search or know, what types of things are here without even going to Onion or Tor sites, this is all just out there, right? This is all just information that's out there about you and your not you, but your organization. And that's really, what ESM is designed to help you out with. So we'll let Abhinav talk about some use cases here for this.
Yeah, so these are some of the key use cases that we feel that ESM could really help with. Heavy cloud migration is one of them. Like we a lot of these companies are going through SaaS transformation and they're migrating cloud. And while they migrate in the process of transition and migration, there's a lot of there's asset management issues that happen and then kind of cause a lot of these assets to go unknown. And ESM definitely can help with that. Merger and acquisition culture is a huge thing. And whenever you want to acquire a company or merge with a company, or even for that matter, third party vendor evaluation, all that, it helps immensely if you can know the cybersecurity posture of that company real quick, right? So before you go through M&A, just make sure that you keep a check on that company's cybersecurity risk through ESM. ESM kind of allows you to quickly, keep monitoring the risk for that company and make sure that make an informed decision around acquisition and merger. Increasing work from home is one big problem, especially for IT and security, both leaders, on how do we keep a track of all these assets. So what ESM does is not only kind of gives you a quick overview of all your assets that are exposed, it gives you information like their geolocation, for example, right? So it kind of makes sure that all the assets that belong to the company stays where they are and known to the IT. Rapid moving culture from people do a lot of database moving, database shifting. Like I said, through as a part of the SaaS transformation, a lot of these assets go dead and unnoticed, and they pose a lot of problems. So ESM definitely can help with that. So these are the use cases, but how do we implement that, right? So adopting ESM is different from like onboarding a network or a client-based security product for that matter, because most of these environments are already known. With ESM, you're dealing with something which is unknown. So the primary use case is to discover and learn that wasn't really previously known about. So so basically, observations, the first part is the noticing, right? So observations are pretty essential to figure out what are those assets. For example, in this case, abandoned IT project. I'm just giving an example of each of those steps to connect the dots. So noticing the first step, you try to identify all the assets. Then you do the theorize, because sometimes when you look at the results, you might be surprised, where do these assets come from? So you build a hypothesis around this. In this case, for example, if there's a zombie telecom asset that we forgot to decommission, right? So you find an asset which is lying somewhere, which you are not aware of. Then you build a hypothesis around it. Make sure third parties validate to make sure that those assets actually belong to you. In this case, pen testing helps, scan helps. You might want to go through the connector integration that you might have just to validate that all these actually applicable to you. Before you validate, there's a huge gap right now because the previous session, a lot of questions came around the credibility of the scan or the crawl. Whatever you find, do they actually belong to you? So that's a part of the validation process. Then you go for analysis. Like in this case, if you find out that telecom asset that you thought does not belong to you, it was actually part of a whole project that were never decommissioned and that's still accessible, right? So, these are the next step after beyond ESM. How do you reconcile those assets and how do you remediate those? So in this case, you analyze this and then you decommission all those assets. Not just that kind of opens up a window for you. Like there might be other assets that were not decommissioned. So you go back to all the IT projects or when the migration happened and make sure that you remediate and get rid of all those assets. So that's how.
Or install the Ivanti agent on them.
Yeah, exactly.
So that you can manage them even though they're in a different cloud.
Right. So that's a full cycle. So it's a full cycle of how do we not just use, but make sure that when you have these kind of assets, they don't really, that never happens again. So it becomes regular practice for the IT and security teams. So just to summarize, so these are three sort of a broad steps in the whole process. Of course, first step is the asset discovery. This includes enumeration, identification for all the elements, all the assets that constitute your attack surface, including hardware assets, networks, application, cloud resource, and everything. Asset profiling comes next, where you make sure that you analyze and validate those assets for you. Make sure the configuration settings and everything is correct. Then classify and prioritize, where you in ESM, neurons for ESM, we use VRS, which is a rating system for vulnerabilities, to prioritize those assets. So sometimes you find exposures and you want to prioritize, okay, which one are the critical ones that I need to fix? Look at the VRS. So, and we kind of give you a funnel, I'll show you in a minute, which helps you prioritize these assets. So that's next step. And then third one, of course, the identify which one do you want to remediate, right? Some of them are like low severity and all. You might want to not worry about it too much. That's, but some of them are like actually your dev environment, which is externally exposed. You might have to fix those first, right? So that's the prioritization and remediation that you want to go through.